So we've got this big log and we're cutting it into fence posts using it. And so you can imagine sort of maybe taking the log and we're splitting it up. So the number of fence posts, number of posts is going to equal the length of the log divided by the length of the posts. Okay, hopefully that makes sense. We've got this log and we are dividing it into the posts. Now, how are we going to get the largest number of fence posts? This is a lower and upper bound problem because we know that the log is 18 meters to correct the nearest meter. Now, this is the thing on the numerator, so we want to make this as big as possible, and we're going to use the upper bound of the length of the log. And then we want to cut it into as many posts as possible. We want the post to be as small as possible because a large number divided by a small number is bigger than a large number divided by a large number. We want to minimize this, so we're going to use the lower bound for that, for the length of the posts. Okay, so if the log is 18 meters, correct the nearest meter, that means the upper bound is going to be 18.5. Any bigger and it would round up to 19. Now 18.5 is the cutoff. So technically it's 18.4999999, and you go on forever, but that is the same as 18.5. And then if we divide by the lower bound of the posts, well, okay, 80 centimeters to correct the nearest 10 centimeters, that's going to be 75 centimeters. But we need to change it to meters, so we're going to divide through by 100, and we are dividing through by 0.75. So that is the key calculation. We can then put that into our calculator, and it gives 24.6 recurring. Now, we can't actually have 0.6 recurring of a fence post, so I think it's absolutely fair to round down to 24 posts, and then I might just write underneath 0.6 recurring meters left over.